Noah time! Noah time!
So guys and gals, it's Noah time. It's probably your last lesson, and so let's make it as a good one. But I'm not gonna draw your picture as always. I'll save it till the end. I want to continue on with what you did last time, and which is this time I'm gonna rotate what happens to the shell when you move the axis of rotation. Axis of rotation. So now the question is, I've been asking you y-axis, x-axis, very easy, very boring. What happened if I change it now? Let's say give you this. It's going to say find the volume of the solid obtained by rotating the region y equals to x minus x squared, y equals to 0, about about x equals to 2. So notice my rotation is not just a simple x or y axis more. I'm rotating about x equals to 2. I change everything. I'm going to pause it, let you have a chance. So if I were to graph this out on a TI-83, I hope you have something that looks like this. Goes up, and then it's down. So my first curve right here, this is y equals to x minus x squared. Now I'm also given another restriction, y equals to 0. So it ends off right here. Therefore, the region that I asked you to rotate is this region right here. I'm going to spin this thing really, really fast around x equals to 2. And I'm going to say that x equals to 2 lies right here. I'm going to pause it and let you figure out what is r in terms of x. That's where the issue lies. If you understand this, that means you're good with the washer and thinking about how to calculate the radius. Is it 2 minus x? You are correct. It's 2 minus x. Now, if you're lost, hands up. I'll come around and I'll show you why it's 2 minus x. Okay. X, would you agree this is r from here to here? Sorry, 4. X is just from anywhere from here to here. This is x. Agreed? 2 is from here to here. Agreed? What is this piece? Thank goodness I was. Hi. Oh, Ruby, you were gone. Full sword. Okay, what's going on? R? So from here to here is 2, agreed? Here to here, we call that just x. That's actually just endpoint. So therefore, this is just 2 minus x. Guys, if you're lost on y is 2 minus x, now we have
Here to here is 2, right?
Whoa. From center to here is 2. Huh?
Yeah, 0 to 2.
Yeah, that's 2. And then here to here is x. At this point, it just x comma y. So figure out. And take 2 minus x. Hey, if you're lost, hello! Yeah, they're all lost. Yeah. So what we're going to do is from here to here, this point is just x comma y. So from here to here is x. From here to here is 2. So therefore, what is this? Whoa, 2 minus x. Right? you're assuming that x is halfway there. X would be here, for example. Then 1 plus x would not give you that's why. Right. Right. Whoa. X is always for the center axis. The y is 0. Right. From here to here, x. No, x is from here to here. It's from right, that's x. Sorry? Right. So guys, if you're lost, watch what I'm going to do. Resume. So from here to here is x. Here to here is 2. So therefore the radius is 2 minus x. And that's how it changes the whole dynamics of everything. In terms of height, well, height is just simply this distance right here, which is y. So now I'm going to plug everything in. And I can actually solve this now. 0, 1. I'm going to put 2 pi to the front. This now becomes 2 minus x, which is radius. The height is just this distance right here, which is just x minus x squared. And go ahead, figure out the rest on your own. You don't need me to walk you through. So if you did this correctly, you should have 2 pi, 0, 1, x cubed minus 3x squared plus 2x. So this now becomes 2 pi x4 over 4 minus x cubed plus x squared from 0 to 1, and you should have pi by 2 if you did it right. I'll give you a few more minutes to try. I'm going to give you one, and here we go. Same concept. Draw this out. The region y equals to 2 root, so this is example 2. Root x minus 1. Y equals to x minus 1. Rotate about x equals to 6. What happens if I give you something like this? I'll pause it. I'm not going to do anything, but I want everyone to follow along. Your graph should look something like this. Something like that. So this is the piece I'm going to rotate right here. And I'm rotating about line equals to x equals to 6. Now x equals to 6, something like that. And I always like to draw the reflection, because when I do, I'm going to create my cylinder. That's what you should have so far. Now, notice I'm working with this value, so here's my cylinder. A lot of you, and the height has to be parallel. Some of you drew your cylinder all the way down here. It doesn't go like that. Your cylinder must stay within the shaded region. You cannot go beyond this. It's impossible. So if you drew it all the way down, you made a boo-boo. My cylinder has to stay within the shaded region. See? Within the shaded region, right there.
Can you do the same thing but on like the bottom half?
Yes, you can. Yep. As long as the height is within the shaded region, you're fine. There's the cylinder. Not the whole big one, but a little skinny one. So the radius is from here all the way to here. Agree? That's r. R, but this point right here, this point is x comma y. So from here to here is x. From here to here is 6. So you can actually calculate r right now. R equals to, Joanna, what's r? 6 minus x. That's r. Before I start, what's the height? What is it? 2 root x minus, make sure you have bracket here. Oh, sorry. 2 root x minus 1. Make sure you have bracket here. X minus 1, height. Or which becomes 2 root x minus 1 minus x plus 1. Because the height is just this piece right here. That's the next confusion people have. So in this question, it looks to be really, really complicated. But I'm going to put everything together and you're going to see how it fits. So I have integral from 1 to 5. Sorry, I'm going to put 2 pi here. 1 to 5. Now, this becomes 6 minus x times 2 root x minus 1 minus x plus 1. I'm going to rewrite this as 2 pi integral 1 to 5. I'm going to expand all this out. You're going to get x squared minus 7x plus 6 plus 12 root x minus 1 minus 2x x minus 1. Take a minute. I want you to compare my work with yours. Here's the next piece. Now, I'm going to take the integral of this. So watch. And this is where it gets tricky. 2 pi. This becomes 1/3 x cubed. Everyone should be able to follow how I got that. Minus 7x squared over 2. Plus 6x. Now here's the tricky part. Plus 8x minus 1, 3 over 2. So what I did here was I rewrote this as 12x minus 1 to the power of 1/2. That's what I did. Okay, but if you take the integral of that, and that's where I got 8 from. This now becomes minus 4, give me 1 second, 3rd x minus 1, 3 over 2, minus 4/5 x minus 1, 5 over 2. I'll explain more to you where this came from after lunch, so don't worry.
Would it be minus 4 over 3x? X minus 1?
Give me 1 second. 1/5. This now becomes 2 pi gives you 136 over 15. And this becomes 272 pi over 15. Now the issue lies, they must know, how did you get the last piece, which is here? I remember what I did now. This piece right here, we say, where did all this weird piece come from? Okay. This actually came from here. So here's what I did. I'm going to look at the integral, just this piece. I'm going to focus on this piece right here. Of 2x root x minus 1. I'm going to use integration by parts. U equals to x minus 1. Du equals to dx. Actually, no, I use substitution. Sorry. X equals to u plus 1. Okay? So then I broke this down into, so 2x root x minus 1 equals to 2u plus 1 times u 1/2 du. So I use substitution. Okay? So I let u be this whole entire thing, agree? So therefore, I go du equals to dx, agree? So here's a dx here. The problem is there's this x on the outside, which I've converted into u. So I found out x equals to u plus 1. So far so good? So here, would you agree this part is x? This part is root x minus 1. And I just brought the 2 to the front. And when I integrated this, what you get is 2 times, becomes u 3 over 2 plus u 1/2 du. Which you will get 2 times 2/5 u 5 over 2 plus 2/3 u 3 over 2. Okay? But I know that u equals to x minus 1, so it becomes 4/5 x minus 1, 5 over 2, plus 4/3, x minus 1, 3 over 2, plus c. And this is where the last piece came from. No, you don't. But that's where the last piece came from. So I went from 5 to 6 pieces because I used integrations by substitution. And your final answer should be 272 pi over 15. I'm going to tell you your work. Down. Page 393. Numero 15 to 25 odd. Please look at number 21. It says do not evaluate for some. They just want you to set it up because it's really long to evaluate some of them. 15 to 20 you should be able to evaluate. But for now, we are going to